Hello, measurement champions. My name is Sylvie Trudel, and on behalf of the COSMIC group, I'll present to you this Module 5, COSMIC Non-Functional Requirements. In this module, you will learn how non-functional requirements can turn into functional requirements and then can be measured. There are topics in other module that you should have viewed, so you are invited to view the other video capsules that we have prepared for you. The content of this video is extracted from this document available for free on the COSMIC website. Is the Non-Functional Requirements and COSMIC Sizing Practitioner's Guide, and it discusses about all these well-known non-functional requirements like performance, maintainability, portability, security, reliability, interfaces, operation, adaptation and installation, safety, resources, human factors, data definition and databases, configuration, and design. Now, non-functional requirements have to be distinguished. There are types of requirements that cannot become functional, such as organizational constraint, location of operations, equipment used, compliance with standards, certain environmental constraint like interoperability, implementation constraint like development language and delivery date. And there are types of requirements that can be non-functional at first and become operational once we refine them, such as quality constraints like reliability, efficiency, environmental constraints like safety, security, etc. Now, those non-functional requirements that are transformable into functional requirements, well, they can be refined, of course, when we know the user requirements better. And here is an example. The ATM system must be able to provide a cash withdrawal service with a high level of security. At a high level, the emphasis is on safety. Now, this presentation is an adaptation of Merigi et al. System Security Requirements, a framework for early identification, specification, and measurement of related software requirements, published at Elsevier in 2019. And of course, we have simplified the example. Now, there are also safety requirements from dependability model for decomposition and allocation of system safety integrity levels of software quality. And here's the model from that paper, where safety is decomposed into external safety and internal safety. So far, at this level, small cloud illustrate a soft goal. Those two here, external and internal, they can be refined further into system functions, and those are operational goals. In every cases where you have a darker cloud that is being shown, it becomes software functionality that can be measured. Let's take another example of the system security, the ATM, where we have different requirements as follows. Requirement 1. The customer must insert his bank card into the ATM, allowing the latter to identify the customer. Requirements 2. After the customer inserts the card, the system extracts the encrypted PIN and asks the user to enter their 8-digit PIN using the keypad to authenticate their identity. Requirement 3. If the customer is authenticated, the ATM system must ensure that the customer daily withdrawals do not exceed $800. Once verified, the customer can access the system. Now, to do this, there are a certain number of plans or control plans that could be put in place. For the 8 a.m. security, there will be, let's say, the user plan authentication that determines at the start of the connection that the calling and or called party identities are authentic. Privacy provides cryptographic mechanisms that protect user data on a virtual channel from unauthorized disclosure. Data integrity provides a mechanism to detect modification of data values or sequences of data values, even in the presence of malicious modification threats. And access control requires mechanism to convey access control information used during connection establishment, as well as mechanism within ATM components to use this information to determine whether access to the connection must be granted. Now, to measure some of these requirements, let's take authentication. Well, to identify the caller, we have an entry, a read, and an exit. And for privacy, to do this, there's an entry, the user code, two reads, the user in the virtual channel, and an exit, the recognition or non-recognition of the user. Well, in reality, this is more complex. Here we simplified the example a lot by considering only one or two data groups. Let's look at Portability NFR. Taken from this paper, a standards-based reference framework for system portability requirements, we've extracted this model, which has four major concepts. The first one, the software component portability. The second one, data component portability. The third one, hardware component portability. And the fourth one, isolation of system calls portability. And many functions or software functions, they will reside on several of the layers once implemented. Let's look at performance non-functional requirements. Well, our user view here can refer to a logical view, a process view, a development view, and a deployment view. And from these views, we can refine the requirements, such as the system performance dynamic requirements, and refine them up until we are able to define the different functions that are required. We can do the same for system performance static requirements. Well, we'll look at these at first. Suppose your user requirement is a 7-day software availability level summary, where the target being 95% availability, which means that the system is functional 95% of the time. The data comes from a tool that you did not develop. On the other hand, if you want to provide a weekly report from the tool's data on the website to your user, you must extract this data and present it in the form of a report. Assuming the information is in a log, so there's one data group called the log, you have an entry for the information coming from the log, an exit for the information presented to the user, a read and an exit for the error message. So the size is 4 COSMIC function points. What would happen if availability and date belong to two different data groups? Could you do the CFP calculation? Well, having not much details, it's difficult. However, what we know, it will be at least one more COSMIC function point. Now, let's look at our example for performance, the one we have 2 slides before. Well, we have here the bandwidth function where bandwidth history log can be created. There's the workload function, which convey the history of the workload. There's response time, a log of the response time. There's setting time function, an interface to set the time function, and a process to show the results. And tracking error function, a log of tracking errors. Now, we identified at least 6 functional processes. And how many COSMIC function points? Well, we would have to look at the requirements, the functional requirements of each of these 6 functional processes. As an exercise, if you want, you can try to define 4 quality standards from the latest project you worked on, and showing how you can measure them as functional process. So those quality standards could be in the categories we've seen earlier, and then try to refine them for your system up until you reach the functional process level of refinement. And if it is not possible, then explain why and use a document you know. It's important to note that you should always keep traceability between a function or functional process and its high-level non-functional requirements. In conclusion, there are a certain number of system requirements which appeared at first glance without measurable software function that can be translated into software functional requirements and be measured with the COSMIC method. Thank you. For further information, please refer to the COSMIC website, where a lot of documentation is available for free. And see you in the next module.